What if I told you that there's a star so massive, so unimaginably powerful, that if it replaced our sun, its surface would extend beyond the orbit of Jupiter? What if I told you that this cosmic monster burns through more material in a single second than our sun will consume in an entire year? And here's the part that will truly blow your mind. This star, called UY Scuti, is so large that if you could somehow travel at the speed of light around its circumference, it would take you over 7 hours to complete the journey. Around our sun, just 14.6 seconds. But that's not even the most terrifying part. The most terrifying part is what happens when stars like this die. Because when UY Scuti finally exhausts its fuel, which could happen tomorrow in cosmic terms, or in 1,000,000 years, it won't just quietly fade away like our sun will. No, it will detonate with a force so violent, so catastrophically powerful, that it could literally sterilize planets hundreds of light years away. And there are dozens of these stellar time bombs scattered throughout our galaxy, some pointing directly at Earth right now. As you're watching this video, UY Scuti is burning at a temperature of 3,365 degrees Celsius on its surface. That's cool for a star, but hot enough to vaporize any known material instantly. Its core? We're talking about temperatures exceeding 100 million degrees. Pressures so intense that they crush atoms into exotic forms of matter that don't exist anywhere else in the universe except in the hearts of dying stars and neutron stars. Of it like this: if Earth were a grain of sand, UY Scuti would be larger than a 3-story house. But unlike a house, this cosmic giant is actively trying to tear itself apart every single second through the sheer force of its own gravity and UCLEAR fury. The only thing keeping it from collapsing into a black hole right now is the incredible nuclear furnace at its core, pushing outward with a force equivalent to billions of hydrogen bombs detonating every second. But here's what's really going to mess with your head. We're not just observers of this cosmic drama, we're participants. Every atom in your body, except for hydrogen, was forged in the nuclear furnace of a star like UY Scuti. The calcium in your bones, the iron in your blood, the oxygen you're breathing right now, all of it was created in the dying moments of massive stars and scattered across the cosmos when they exploded. You are literally made of ancient starlight. And if that doesn't make you pause and reconsider your place in the universe, wait until you learn what scientists discovered in 2021. That changes everything we thought we knew about these stellar giants. Let's start with something that seems simple, but will completely reframe how you think about stars. When you look up at the night sky, what you're seeing is essentially cosmic false advertising. Those twinkling points of light? They're lying to you about their true nature. Most of the stars you can see with the naked eye are actually relatively small, dim objects, cosmic lightweights compared to the true monsters lurking in the depths of space. UY Scuti, the current record holder for the largest known star by radius, is so far away, about 9,500 light years, that despite being roughly 1,700 times larger than our sun, it's completely invisible to the naked eye. You need a telescope just to detect its feeble glow. This seems contradictory, doesn't it? How can the biggest star be invisible while smaller stars blaze across our night sky? Here's the twist that reveals something profound about the universe. Size doesn't equal brightness. UY Scuti is what astronomers call a red supergiant, a star in its death, throes that has expanded to an enormous size, but cooled significantly in the process. Think of it like a campfire that's dying down. As the flames get weaker, they spread out and turn from white-hot to red, covering a much larger area, but producing less intense heat per square inch. The German astronomer who first cataloged this cosmic giant, astronomers at the Bonn Observatory in 1860 had no idea they were looking at a star that could swallow our entire solar system. They simply noted it as a variable star, one that changes brightness over time. It wasn't until 2012 that a team led by Felipe Massi used the Hubble Space Telescope and advanced interferometry to measure its true size, and the results shattered records. But here's where things get really interesting. Scuti isn't just big, it's unstable. The star is literally pulsating, expanding and contracting like a cosmic heartbeat. Over a period of about 740 days, it swells and shrinks by amounts that would encompass the entire orbit of Mars. Imagine if our sun suddenly started growing and shrinking so dramatically that it would alternately swallow and release Mars every 2 years. The gravitational chaos would tear our solar system apart. This pulsation is a sign that Scuti is fighting a losing battle against its own gravity. Deep in its core, the nuclear fusion that has powered it for millions of years is starting to falter. The star is now fusing heavier and heavier elements: carbon, oxygen, silicon, each step releasing less energy than the last. It's like a car running out of gas, the engine sputtering as it tries to keep running on fumes. And here's what will blow your mind about stellar evolution. Scuti probably didn't start out as a giant. It likely began its life as a star only. 20 to 30 times more massive than our sun, still huge, but nothing compared to its current bloated state. Think of it like a bodybuilder who suddenly stops exercising and their muscles turn to fat. Except in this case, the fat is an envelope of gas larger than Jupiter's orbit. The transformation from a compact, blazing hot star to this red supergiant happened relatively quickly in cosmic terms, probably within the last few million years. That means if you could travel back in time to when early humans were just starting to walk upright, you would see Scuti as a brilliant blue star, possibly visible to the naked eye despite its distance. But the most mind-bending part is yet to come, because what Scuti is doing right now, this cosmic expansion, this stellar death dance, is creating the very elements that make complex life possible. What if I told you that the reason you can think, feel, and exist is because of the violent death of stars exactly like Scuti? Not metaphorically, not poetically, but literally. The nuclear fusion process is happening in Scuti's core right now are manufacturing the building blocks of consciousness itself. Let me paint you a picture that will change how you see yourself forever. In Scuti's core, temperatures reach 200 million degrees Celsius. That's 13 times hotter than the sun's core. At these impossible temperatures, carbon atoms are being fused together to create oxygen. Oxygen atoms are being combined to produce silicon. Silicon is being forged into iron. And in the final desperate moments of Scuti's life, iron will be transmuted into cobalt, nickel, and dozens of other heavy elements through a process so violent it defies imagination. The brilliant astrophysicist Carl Sagan famously said, "We are made of star stuff," but most people don't truly grasp what that means. Let me make it concrete for you. The iron in your blood, the iron that carries oxygen from your lungs to your brain right now, allowing you to understand these words, that iron was forged in the collapsing core of a massive star during the most violent event in the known universe. A supernova explosion. Not think of it like this. Every red blood cell in your body contains about 280 million iron atoms. Each of those atoms was created in temperatures and pressures so extreme that if you could somehow recreate them on Earth, they would instantly vaporize our entire planet. You are walking around with the cremated remains of dead stars flowing to your veins. But here's where it gets even more incredible. The calcium in your bones, the phosphorus in your DNA, the sulfur in your proteins, all of these elements require the death of massive stars to exist. Hydrogen and helium were created in the Big Bang, but everything else, everything that makes you more than just a cloud of primordial gas, requires stellar nucleosy NTHEs. Professor Jennifer Johnson at Ohio State University calculated that the average human body contains about 97% stellar material. You're not just connected to the universe, you are the universe, literally made from the recycled corpses of ancient suns. The star that donated the calcium in your bones might have exploded billions of years ago, its death cry echoing across the cosmos long before Earth even existed. Now here's what's really going to blow your mind. UY Scuti is so massive that when it dies, and we'll talk about exactly how that happens in a moment, it will create and scatter enough heavy elements to potentially form thousands of planets like Earth. The star you're learning about right now might be manufacturing the building blocks for alien civilizations that won't exist for billions of years. But UY Scuti is also doing something else, something that most people never consider. It's acting like a cosmic time machine. The light you see from UY Scuti through a telescope left that star 9,500 years ago. You're literally seeing the star as it was when humans first invented agriculture. The UY Scuti of today, the one that exists right now as you watch this, might have already exploded, and we won't know for almost 10,000 years. This creates a profound philosophical puzzle. Is UY Scuti real if we can never know its current state? Are we studying a ghost, a stellar memory frozen in time? And here's the part that should keep you awake at night. If UY Scuti exploded 5,000 years ago, the wave of deadly radiation is already halfway here, racing toward Earth at the speed of light, invisible and undetectable until the moment it arrives. But before we dive into that terrifying possibility, let me show you something that will make UY Scuti's size even more mind-boggling. Here's something that will completely break your brain. UY Scuti is so large that if you were somehow standing on its surface, which you couldn't, because it doesn't really have a surface in the way we understand it, you wouldn't even realize you were on a star. The curvature would be so gradual that the horizon would appear completely flat in every direction, just like it does on Earth, but for completely different reasons. Let me help you visualize this with an analogy that will stick with you forever. Think of our sun as a ping pong ball. On that scale, Earth would be a grain of sand orbiting about a meter away. Mercury would be a speck of dust about 30 centimeters from the ping pong ball. Now, UY Scuti on the same scale would be a sphere about 3.5 meters in diameter, larger than most people are tall. Jupiter's orbit around our ping pong ball sun would fit comfortably inside UY Scuti, with room to spare. But here's where it gets truly bizarre. Despite being 1,700 times larger than our sun, UY Scuti only contains about 30 times more mass. How is this possible? It's because UY Scuti is incredibly diffuse. Its outer layers are essentially a hot vacuum, thousands of times thinner than Earth's atmosphere. If you could somehow scoop up a cubic meter of material from UY Scuti's outer envelope, it would weigh less than a single breath of air at sea level. This mind-bending fact reveals something profound about the nature of matter and gravity. UY Scuti is held together not by the density of its material, but by the cumulative effect of gravity acting across an incomprehensibly vast volume. Every single atom in that enormous envelope, no matter how far from the center, is being pulled inward by the combined gravitational attraction of all the other atoms. Dr. Emily Levesque, an astrophysicist at the University of Washington who has studied red supergiants extensively, discovered something remarkable in 2020. She found that stars like UY Scuti exist in a constant state of near gravitational collapse, prevented from imploding only by the outward pressure of radiation from their cores. Remove that radiation pressure for even a few minutes, and the star would collapse faster than you could blink. Think of it like this. Imagine a soap bubble the size of a football stadium held inflated not by air pressure, but by a tiny nuclear bomb going off at the center every second. That's essentially what Scuddy is, an incredibly delicate balance between the most powerful explosion in the universe, nuclear fusion, and the most relentless force in the universe, gravity. This precarious balance explains why Scuddy pulsates so dramatically. Small changes in the fusion rate at the core create ripple effects that cause the entire star to expand and contract over periods of years. During its expansion phases, Scuddy's outer layers actually cool down so much that they're barely hotter than molten lava. During contraction, they heat up enough to ionize any atoms they encounter. But here's what's really going to mess with your head. Because Scuddy is so large, different parts of the star are experiencing time at slightly different rates due to gravitational time dilation. Einstein's theory of general relativity tells us that time moves slower in stronger gravitational fields. An observer at Scuddy's surface would experience time about 0.0002% slower than someone at the star's center. This might not sound like much, but over the millions of years of Scuddy's lifetime, this time dilation effect means that different parts of the star are literally aging at different rates. The core is evolving faster than the surface layers, creating a cosmic generation gap within a single object. And here's the truly mind-bending part. If you could somehow survive in Scuddy's outer envelope, you could potentially watch the stars' internal evolution in real time. The convection currents in red supergiants are so powerful that material from deep inside the star regularly bubbles up to the surface, carrying with it the nuclear products of fusion reactions that occurred in the core dot. You would be witnessing stellar alchemy in action, watching carbon transform into oxygen, oxygen into silicon, silicon into iron. You'd be seeing the universe create complexity from simplicity, watching the cosmic forge that made the building blocks of planets, life, and consciousness itself. But this beautiful process has a dark side, because every fusion reaction brings Scuddy one step closer to a catastrophe that could affect us here on Earth. If I told you that there are stellar explosions so powerful, they can be seen from literally billions of light years away, across the entire observable universe? And what if I told you that Scuddy is destined to become one of these cosmic monsters, a hypernova explosion that will release more energy in 10 seconds than our sun will produce in its entire 10 billion year lifetime? Here's what's happening. Inside Scuddy right now, it's building toward this apocalyptic finale. In the star's core, nuclear fusion is proceeding through what astronomers call the silicon burning phase. This isn't burning in the sense of fire. It's the fusion of silicon atoms into iron under conditions so extreme that they would make the center of a hydrogen bomb look like a gentle summer breeze. The temperature in Scuddy's core has now reached 3 billion degrees Celsius. At these temperatures, silicon atoms are moving so fast they can overcome their electrical repulsion and fuse together. But here's the crucial detail that changes everything. Iron is the most stable nucleus in the universe. When silicon fuses into iron, it releases energy. When iron tries to fuse into heavier elements, it absorbs energy. Think of it like this. Imagine nuclear fusion as a ball rolling downhill, releasing energy as it goes. Hydrogen fuses into helium, energy released. Helium into carbon, more energy. Carbon into oxygen, oxygen into silicon. The ball keeps rolling downhill, releasing energy that keeps the star shining. But iron is at the bottom of the hill. Try to push that ball further uphill into heavier elements, and you need to put energy in rather than getting energy out. This means that once Scuddy's core fills up with iron, a nuclear furnace that has been supporting the star against gravity for millions of years suddenly shuts off. And when I say suddenly, I mean suddenly. The transition from a functioning star to gravitational collapse happens in less than a second. Dr. Adam Burrows at Princeton University has run supercomputer simulations of exactly what happens next, and the results are terrifying. When the nuclear fire goes out, gravity wins instantly. The core of UY Scuti, an object the size of Earth but containing the mass of several suns, collapses from 5,000 kilometers in diameter to just 20 kilometers in diameter in about a quarter of a second. The collapse happens so fast that the iron nuclei in the core are crushed together with such force that protons and electrons are literally squeezed together to form neutrons. The core becomes so dense that a teaspoon of this material would weigh as much as Mount Everest. This is the SHE, birth of a neutron star, an object so dense that its gravity warps space and time around it. But the collapse doesn't stop there. The infalling outer layers of UY Scuti, still carrying the momentum of gravitational collapse, slam into this newly formed neutron star at about 30,000 kilometers per second, 10% of the speed of light. The collision is so violent that it creates a shockwave that rips back up through the star, heating the stellar material to temperatures exceeding 10 billion degrees. Here's where the truly mind-bending physics kicks in. At these temperatures, the shockwave triggers a cascade of nuclear reactions that create elements heavier than iron, gold, platinum, uranium, elements that can only be forged in the ultimate furnace of stellar death. The explosion that will mark the end of UY Scuti will create more gold in a few seconds than our sun will produce in its entire lifetime. But the most terrifying aspect isn't the creation of heavy elements, it's the sheer amount of energy released. When UY Scuti explodes as a hypernova, it will briefly outshine the entire galaxy it resides in. For a few weeks, this single dying star will be brighter than the combined light of 400 billion other stars. The explosion will launch material into space at speeds approaching 20,000 kilometers per second, creating an expanding shell of superheated gas and radiation. This stellar debris will race through space for thousands of years, sweeping up interstellar material and creating shockwaves that can trigger the formation of new stars in nearby gas clouds. And here's the part that should genuinely concern us. Depending on UY Scuti's orientation when it explodes, it could direct a focused beam of gamma radiation directly at Earth. Here's something that will make you question whether we should even be talking about UY Scuti. There's a small but non-zero possibility that this star could kill everyone on Earth, and we wouldn't see it coming until it was too late to do anything about it. The weapon? Gamma-ray bursts, the most powerful explosions known to physics since the Big Bang itself. When massive stars like UY Scuti collapse into neutron stars or black holes, they don't always explode symmetrically. Sometimes the collapse and subsequent explosion creates two focused beams of gamma radiation that shoot out from the star's poles like cosmic laser beams. These beams are so intense, so perfectly collimated, that they can be detected from literally the other side of the observable universe. Dr. Neil Gehrels, the late NASA astrophysicist who pioneered gamma-ray burst research, calculated that a typical long-duration gamma-ray burst releases more energy in 10 seconds than our sun will produce in its entire 10 billion-year lifetime. The beam is so tightly focused that it concentrates this energy into a cone with an opening angle of just a few degrees. Think of it like this. Imagine taking all the energy our sun will ever produce and focusing it into a laser beam narrower than the width of your thumb held at arm's length. That's the level of energy concentration we're talking about. If UY Scuti produces such a beam when it explodes, and if Earth happens to be in the path of that beam, the results would be catastrophic. Here's what would happen if a gamma-ray burst from UY Scuti hit Earth. The initial pulse of gamma rays would strip away our planet's ozone layer in a matter of seconds. Without the ozone layer to protect us from ultraviolet radiation, the sun's UV light would become lethal to most life forms. Plants would begin to die within days, disrupting the entire food chain. But the gamma rays themselves would be even more immediately deadly. The radiation dose would be equivalent to detonating a nuclear weapon in Earth's upper atmosphere, creating a global electromagnetic pulse that would destroy electronic systems worldwide. The radiation would cause immediate and fatal radiation sickness in any humans or animals exposed to it. Professor Brian Thomas at Washburn University has studied the effects of nearby gamma-ray bursts on Earth's biosphere. His research suggests that a burst from a star like Scuti, even at its distance of 9,500 light-years, could cause a mass extinction comparable to the one that killed the dinosaurs. The difference is that instead of an asteroid impact, the extinction would come from the death cry of a distant star. But here's the truly unsettling part. We have no way to predict exactly when Scuti will explode. And more importantly, we have no way to know if its rotation axis is pointed at Earth. The star could be oriented such that when it collapses, one of its gamma-ray beams would sweep across our solar system like a cosmic lighthouse beam. Current estimates suggest Scuti could explode anywhere from tomorrow to 1,000,000 years from now. In cosmic terms, that's essentially any moment. And because the explosion would travel at the speed of light, we would have no warning. The first sign would be Earth's atmosphere beginning to glow and heat up as the gamma rays interacted with our air dot. However, before you start building a bunker, let me give you some perspective. The chances of Scuti's gamma ray being pointed directly at Earth are roughly 1 in 100. Most gamma ray bursts are pointed away from us, shooting their deadly radiation harmlessly into space. We've been lucky so far in the 4.5 billion year history of our planet. We've probably been hit by gamma ray bursts before, but none powerful enough to cause complete sterilization. But here's what makes this even more complex. Scuti isn't the only massive star in our cosmic neighborhood. There are dozens of other potential gamma-ray burst sources within 10,000 light-years of Earth. Stars like Eta Carinae, Betelgeuse, and WR-104 are all ticking time bombs that could potentially affect our planet. And this brings us to a profound realization about our place in the universe. We exist in a cosmic shooting gallery, surrounded by stellar weapons of mass destruction that could end life on Earth in an instant. Yet somehow, despite billions of years of cosmic violence, life has not only survived, but thrived. This paradox reveals something beautiful about the universe. It's simultaneously the most dangerous and most nurturing environment imaginable. The same stellar explosions that could destroy us are also the source of every element in our bodies, except hydrogen. Here's something that will completely reframe how you think about your morning coffee. The caffeine molecule you're about to consume contains carbon atoms that were forged in the nuclear furnace of a star like Scuti. Oxygen atoms created in a slightly smaller stellar explosion. Nitrogen atoms manufactured in the death throes of a massive star. And hydrogen atoms that have existed since the universe was 3 minutes old. That single molecule of caffeine is older than Earth itself, a cosmic traveler that has journeyed through space for billions of years before ending up in your cup. And here's the mind-bending part. The nuclear reactions that created those atoms released enough energy to power our current civilization for millions of years. Let me paint you a picture that will change how you see everything around you. Look at your hand. The phosphorus in your DNA was created when a star about 20 times the mass of our Sun exhausted its nuclear fuel and exploded in a supernova. The explosion was so violent that it briefly outshone the entire galaxy, scattering phosphorus atoms across thousands of light-years of space. That those phosphorus atoms drifted through the cosmos for perhaps billions of years, slowly accumulating in a cloud of gas and dust that eventually collapsed to form our solar system. They were incorporated into the early Earth, dissolved in ancient oceans, absorbed by primitive life forms, and eventually became part of the genetic code. That makes you uniquely you. But here's what's really going to blow your mind. This process is still happening. Right now, as you're watching this video, stars like you, Scotty, are manufacturing the building blocks for life forms that won't exist for billions of years. The oxygen you're breathing, the carbon in your DNA, the calcium in your bones, all of it is being created, fresh in stellar cores throughout the universe. Professor Maria Lugaro at Concolly Observatory has calculated that the average human body contains atoms from at least 40 different stellar explosions. You are not just made of star stuff. You are made of the combined deaths of dozens of individual stars, each one a cosmic tragedy that became a building block of consciousness. Think of it like this. Every atom in your body is a cosmic refugee, a survivor of stellar violence that has traveled unimaginable distances to become part of you. The iron in your blood might have been forged in a star that exploded before our sun was even born. The calcium in your bones could have been created in a supernova explosion that lit up the night sky of some alien world millions of years ago. This isn't just poetic, it's literally true. Stellar nucleosynthesis is the only known mechanism in the universe capable of creating elements heavier than lithium. Everything else, the oxygen you breathe, the carbon in your cells, the metals in your smartphone, all of it was forged in the nuclear furnaces of dying stars. But here's where it gets really profound. This means that consciousness itself is a product of stellar death. The complex chemistry that makes thought possible, the intricate dance of neurotransmitters in your brain, the electrical impulses racing along your neurons, all of it depends on elements that can only be created when massive stars die. Are not just an observer of the universe. You are the universe becoming aware of itself. You are billions of years of cosmic evolution manifesting as consciousness, a way for the cosmos to examine its own history and contemplate its own future. And here's something that should fill you with wonder. When Scotty finally explodes, it will scatter enough heavy elements into space to potentially create thousands of Earth-like planets. Each of those worlds might eventually harbor life, consciousness, intelligence. The death of Scotty isn't just an ending, it's a beginning, a cosmic seed that will give birth to new forms of complexity and awareness. But this beautiful process comes with a dark reality that most people never consider. Stellar death is not just creative, it's also destructive on a scale that dwarfs anything we can imagine. What if I told you that stellar explosions are so powerful, they can literally punch holes through space itself, creating regions where the normal rules of physics break down completely? What if I told you that when Scotty explodes, it might not just become a neutron star, but could collapse into something even more extreme, a black hole, so massive it defies our current understanding of stellar evolution? Here's where the story of Scotty takes a turn into the truly bizarre. Recent computer simulations by Dr. Alexander Heger at Monash University suggest that stars this massive don't always follow the standard supernova playbook. Instead of exploding and leaving behind a neutron star, Scotty might undergo what's called direct collapse, a process so violent it skips the explosion phase entirely. In direct collapse, the star's core becomes so massive during its final moments that not even the nuclear explosion of a supernova can stop the gravitational collapse. The entire star simply falls into itself, creating a black hole in a matter of seconds. But this isn't just any black hole. We're talking about a stellar mass black hole containing 30 to 40 times the mass of our sun, all compressed into a region smaller than Manhattan. Think of it like this. Imagine taking the entire mass of Scotty, a star so large it could swallow Jupiter's orbit, and compressing it down to a point smaller than the period at the end of this sentence. The gravitational field around such an object becomes so intense that it literally warps space and time into a funnel-shaped pit from which nothing, not even light, can escape. But here's what's really going to mess with your head. The formation of this black hole would create ripples in space-time itself, gravitational waves that would race across the universe at the speed of light. When these waves reached Earth, they would cause the entire planet to stretch and compress by amounts smaller than the width of a proton. But sensitive instruments like LIGO would detect them as a characteristic chirp in the data. Dr. Kip Thorne, the Nobel Prize-winning physicist who predicted gravitational waves decades before they were detected, calculated that the collapse of a star like UY Scuti would create gravitational waves 1,000 times stronger than the merging black holes we've already observed. For a brief moment, the gravitational wave energy passing through Earth would exceed the power output of all the stars in the observable universe. But black holes created from stars like UY Scuti don't just sit quietly in space. They're incredibly active violet objects that feed on anything unfortunate enough to fall into their gravitational well. As matter spirals into the black hole, it forms what's called an accretion disk, a swirling maelstrom of superheated gas moving at significant fractions of the speed of light. The friction in this accretion disk heats the infalling matter to temperatures exceeding 1 billion degrees, causing it to emit X-rays so intense they can be detected from across the galaxy. Some of this matter doesn't fall into the black hole at all. Instead, it gets accelerated along the black hole's magnetic field lines and shot out into space as jets moving at 99.9% of the speed of light. These relativistic jets are among the most powerful phenomena in the universe, capable of punching through entire galaxies and creating structures hundreds of thousands of light years long. If UY Scuti becomes such a black hole, and if one of its jets is pointed toward Earth, the high-energy radiation could be even more dangerous than a gamma-ray burst. Here's where the physics gets truly mind-bending. Near the event horizon of a black hole created from UY Scuti, time itself would slow to a crawl due to gravitational time dilation. If you could somehow survive the journey to the edge of the black hole and look back at Earth, you would see the entire future history of our planet play out in fast-forward, billions of years of evolution, the death of our sun, the eventual heat death of the universe, all compressed into what would feel like a few hours to you. But perhaps the most profound aspect of stellar mass black holes is what they represent, the ultimate triumph of gravity over every other force. In the universe, not even the nuclear forces that power stars, not even the quantum mechanical pressure that supports neutron stars, can resist the gravitational collapse once it begins. The matter that once comprised UY Scuti would be crushed down to infinite density at the black hole's center, a point where our current physics breaks down completely, and we must admit ignorance about what really happens. And yet, even this cosmic violence serves a purpose in the grand scheme of things. Black holes aren't just destroyers. They're also cosmic recycling centers, slowly feeding energy back into the universe through Hawking radiation and playing crucial roles in galaxy formation and evolution. Here's something that will change how you think about destruction and creation. The most violent events in the universe are also the most creative. When UY Scuti dies, whether in a supernova explosion or direct collapse to a black hole, it won't just end. It will become a cosmic artist, painting new structures across space and seeding the universe with the raw materials for future generations. Of stars and planets, let me show you how stellar death becomes cosmic birth. When a star like UY Scuti explodes, it doesn't just scatter its material randomly into space. The explosion creates an expanding shell of superheated gas and stellar debris called a supernova remnant. This shell races through space at thousands of kilometers per second, sweeping up interstellar gas and dust like a cosmic snowplow. Dr. Lavra Lopez at Ohio State University has studied these supernova remnants using X-ray telescopes. And what she's discovered is remarkable. The expanding shell doesn't just push material aside, it compresses it, creating dense pockets of gas that become stellar nurseries. The death of one massive star can trigger the birth of hundreds of new stars in the surrounding region. Think of it like this. Imagine dropping a stone into a perfectly still pond. The ripples that spread out from the impact point are like the expanding shockwave from UY Scuddy's explosion. But instead of just disturbing the water, these cosmic ripples compress interstellar gas clouds, causing them to collapse under their own gravity and form new stars. This process, called triggered star formation, means that UY Scuddy's death will echo through the galaxy for millions of years. Stars born from the compressed gas in its supernova remnant will themselves live, evolve, and die, potentially triggering even more star formation. It's a cascade of creation powered by destruction, a cosmic chain reaction that links the death of ancient stars to the birth of future solar systems. But the creative power is stellar. Death goes far beyond just making more stars. The explosion of UY Scuddy will inject the interstellar medium with heavy elements: carbon, oxygen, silicon, iron, and dozens of others that are essential for planet formation and life. These elements, forged in the stellar furnace and scattered by the explosion, will become the building blocks of rocky planets orbiting future stars. Professor Ken Nomoto at the University of Tokyo has calculated that a single supernova like UY Scuddy will explode with enough energy to create and disperse several Earth masses worth of heavy elements. That's enough raw material to potentially form thousands of terrestrial planets, each one carrying the chemical legacy of the dead star that created it. Here's where it gets really mind-bending. The explosion will also create isotopes that don't exist naturally anywhere else in the universe. Radioactive elements like aluminum-26 and iron-60, with half-lives of millions of years, will be scattered into space where they'll serve as cosmic clocks, allowing future astronomers to determine when and where the explosion occurred. Scientists have actually found traces of these stellar explosion isotopes in meteorites and ancient rocks on Earth, providing direct evidence that supernova occurred near our solar system in the past. In 2016, researchers discovered deposits of iron-60 in deep ocean sediments, indicating that a supernova occurred within about 300 light-years of Earth, roughly 2.6 million years ago. This discovery is profound because it means we can read the history of stellar explosions in our own planet's geological record. Earth itself is a library of cosmic violence, preserving the signatures of dying stars in its rocks and sediments. But here's what's really going to blow your mind about the creative power of stellar death. The shock waves from supernova explosions don't just compress gas to form new stars. They can actually accelerate particles to nearly the speed of light, creating cosmic rays that rain down on Earth every second of every day. Right now, as you're reading this, your body is being bombarded by high-energy particles that were accelerated by stellar explosions throughout the galaxy. These cosmic rays are so energetic that they can penetrate deep underground, and some of them carry more energy than the most powerful particle accelerators on Earth. You are literally being touched by the death cries of distant stars. Dr. Elena Amato at the Archetri Astrophysical Observatory has shown that supernova shock waves act like cosmic particle accelerators, using magnetic fields to whip protons and atomic nuclei to incredible energies. Some cosmic ray particles carry so much energy that when they hit Earth's atmosphere, they create particle showers that can be detected across areas larger than entire cities. And here's the connection that will make you see yourself differently. These cosmic rays play a crucial role in evolution itself. When high-energy cosmic ray particles strike DNA molecules, they can cause mutations. Most of these mutations are harmful or neutral, but occasionally, they create beneficial changes that give organisms an evolutionary advantage. This means that stellar explosions throughout the galaxy are constantly reshaping life on Earth in subtle ways. The genetic diversity that makes evolution possible, the mutations that drive adaptation and speciation, some of them are literally caused by the death throes of massive stars like you. Why? Scuddy, you are not just made of star stuff. You are being actively shaped by stellar violence on a moment-by-moment basis. But the most profound realization comes when you consider the timeline. UY Scuddy has been influencing Earth's environment for its entire existence. The star's powerful stellar winds, carrying heavy elements, manufactured in its core, have been enriching the interstellar medium around our solar system for millions of years. Some of the oxygen you're breathing right now might have been created in UY Scuddy's nuclear furnace and carried to our region of space by stellar winds. Think of it like this. UY Scuddy isn't just a distant object we observe through telescopes. It's an active participant in the cosmic ecosystem that makes life on Earth possible. Its nuclear reactions, its stellar winds, its eventual explosive death, all of these are part of a vast, interconnected web of stellar processes that created and continue to sustain the conditions necessary for consciousness to exist. And this brings us to perhaps the most mind-bending realization of all. When you look up at UY Scuddy through a telescope, you're not just observing a star. You're looking at a cosmic factory that's manufacturing the elements that will someday become part of future living beings. You're witnessing the universe's way of creating complexity, consciousness, and ultimately, meaning itself. What if I told you that right now, in this very moment, you are participating in the most extraordinary experiment in the history of the universe? What if I told you that your existence as a conscious, thinking being represents the culmination of nearly 14 billion years of cosmic evolution, and that stars like UY Scuddy are the reason this experiment is possible at all? Here's something that will fundamentally change how you see your place in the cosmos. Consciousness is not an accident. It's not a random byproduct of chemical reactions in your brain. Consciousness is the universe's way of examining itself, understanding itself, and perhaps even directing its own future evolution. Think about what's happening right now as you process these words. You're taking patterns of light reflected off your screen or sound waves vibrating through the air and somehow transforming them into thoughts, images, emotions, and understanding. You're converting electromagnetic radiation into consciousness itself, and the atoms making this possible, the carbon in your neurons, the phosphorus in your brain's energy molecules, the calcium regulating your neural impulses, all of it was forged in stellar furnaces like the one burning in UY Scuddy's core right now. Professor Sean Carroll at Caltech has proposed something called the emergence hypothesis, the idea that consciousness emerges from complex arrangements of ordinary matter when those arrangements reach a critical level of information processing capability. But here's what makes this profound. Those complex arrangements are only possible because of the heavy elements created in stellar explosions. In a universe with only hydrogen and helium, a universe without stellar nucleosynthesis, there could be no complex chemistry, no organic molecules, no DNA, no brains, no consciousness. The universe would be forever dark and empty, filled with simple gas clouds, but devoid of any way to examine or understand itself. You are the universe becoming self-aware. When you look up at the night sky and feel wonder, that's cosmic matter, contemplating its own origins. When you try to understand how stars work, that's stellar material investigating the processes that created it. When you feel amazed by the size and power of UY Scuddy, that's the universe experiencing awe at its own creative capacity. But here's where it gets really mind-bending. Your consciousness might actually be influencing the future evolution of the cosmos. Through science and technology, conscious beings like humans are beginning to understand and potentially manipulate stellar processes. We're learning to recreate stellar nucleosynthesis in fusion reactors, to detect gravitational waves from stellar collisions, to predict, can possibly even prevent stellar explosions that could threaten Earth. Dr. Martin Rees, the astronomer royal, has speculated that sufficiently advanced civilizations might eventually learn to control stellar evolution, preventing stars from exploding prematurely or directing their energy output for cosmic engineering projects. If this is possible, then consciousness isn't just a passive observer of cosmic evolution. It's an active participant that could shape the future of stars, galaxies, and the universe itself. This means your existence has cosmic significance. You're not just a random collection of atoms that happen to achieve self-awareness. You're part of the universe's ongoing project of understanding itself and potentially directing its own future development. Every time you learn something new about stars, planets, or the cosmos, you're advancing this cosmic project of self-discovery. And here's something that should fill you with profound responsibility. If consciousness is indeed rare in the universe, if Earth is among the first planets to evolve self-aware beings, then we might be the universe's first attempt at understanding itself. The choices we make, the knowledge we gain, the wisdom we develop, all of it could influence whether consciousness spreads throughout the cosmos or remains confined to our single world. When Scuddy eventually explodes, it will scatter the elements necessary for countless new worlds and potentially new forms of consciousness. But whether those elements actually become conscious beings might depend on what we learn and do right now. We might be the universe's way of ensuring that consciousness, once achieved, is preserved and propagated throughout space and time. Think of it this way. You are not just made of star stuff. You are star stuff that has learned to think, to wonder, to question, and potentially to create. You are the cosmos examining itself through human eyes, thinking about itself with a human brain, marveling at its own beauty and complexity through human emotions. And this realization should change everything about how you see yourself and your life. Here's what will change your perspective on everything. The fact that you exist at all is so statistically improbable, so dependent on an impossibly precise sequence of cosmic events, that many physicists argue it's the most extraordinary thing that has ever happened in the universe. And stars like Scuddy played an essential role in making your existence possible. Let me walk you through the cosmic miracle that is your life. First, the universe had to expand at exactly the right rate after the Big Bang. A tiny bit faster, and matter would have spread out too quickly for stars to form. A tiny bit slower, and everything would have collapsed back into a black hole before. Stars could ignite. The margin of error? 1 part in 1060. That's more precise than hitting a target the size of a coin from 14 billion light years away. Then, the first generation of massive stars, stars even larger than Scuddy, had to form, live, and die to create the heavy elements necessary for rocky planets and complex chemistry. This process took billions of years, during which the universe had to remain stable enough for stellar evolution to proceed, but dynamic enough for new generations of stars to keep forming. Your solar system formed from a cloud of gas and dust that contained the recycled remains of dozens of previous stellar explosions. The timing had to be perfect, too early, and there wouldn't have been enough heavy elements. Too late, and the galaxy might have evolved past the point where Earth-like planets could form inhabitable zones around sun-like stars. Dr. Rare Earth hypothesis, proposed by Peter Ward and Donald Brownlee, suggests that complex life requires such a specific set of conditions that Earth might be nearly unique in the galaxy. But here's what's amazing. Every one of those conditions ultimately traces back to stellar processes like the ones happening in Scuddy right now. The magnetic field that protects Earth from cosmic radiation, it's powered by radioactive decay of elements created in stellar explosions. The plate tectonics that regulate our climate and create continents? They're driven by heat from radioactive elements in Earth's core, elements that were forged in the hearts of dying stars. The oxygen you breathe? It was created by stellar nucleosynthesis and then concentrated in our atmosphere by billions of years of photosynthesis. But here's the part that will really blow your mind. You almost didn't exist. Not just as an individual, though that's amazing enough, but as a species, as a form of life, as a type of conscious being. Earth has experienced at least 5 mass extinctions, each one potentially capable of preventing human evolution. Some of these extinctions might have been caused by nearby stellar explosions, gamma-ray bursts, or other cosmic catastrophes. And yet, here you are. Against all odds, through billions of years of cosmic violence and stellar death, through planetary catastrophes and evolutionary bottlenecks, through the precise fine-tuning of physical constants and the exact timing of stellar evolution, you exist. You are conscious. You can think about the stars that made you possible. Professor Max Tegmark at MIT has calculated the probability of a universe like ours arising by chance, with all the right physical constants and conditions for complex life. The number he came up with has more zeros than there are atoms in the observable universe. You are not just unlikely, you are miraculous in the most literal, mathematical sense. But this miraculous nature of your existence comes with profound implications. If consciousness is this rare, this difficult to achieve, this dependent on precise cosmic conditions, then it might be the most valuable thing in the universe. Your thoughts, your experiences, your capacity for wonder and understanding, these might be the rarest and most precious phenomena in all of existence. When you look up at UY Scuti and feel amazed by its size and power, you're experiencing something that might be unique in the cosmos. That sense of wonder, that capacity to be awed by the universe's beauty and complexity, might exist nowhere else within thousands of light years. You might be the only conscious being in this entire region of space capable of appreciating the cosmic drama unfolding in stellar cores throughout the galaxy. This makes your life infinitely precious, not just to you and those who love you, but to the universe itself. You are the cosmos experiencing subjective awareness for possibly the first and only time in this corner of space. When you learn something new about stars or planets, or the nature of reality, you're adding to the universe's knowledge of itself. Here's what should inspire you. If consciousness is this rare and precious, then preserving it, expanding it, and sharing it might be the most important thing any conscious being can do. Every time you teach someone else about the wonders of the universe, every time you inspire wonder in another person, you're helping to spread the most valuable thing in existence. But this precious nature of consciousness also comes with a sobering reality. It's fragile, and it exists in a universe filled with threats like the ones we've been discussing. Here's something that will put everything we've discussed into a perspective that should both humble and inspire you. Right now, at this very moment, there are dozens of stellar time bombs within 10,000 light years of Earth, any one of which could potentially end human civilization. And yet, the very existence of these cosmic weapons is also what makes our existence possible in the first place. Let me paint you a picture of our cosmic neighborhood that will change how you see our place in the galaxy. Within 8,000 light years of Earth, close enough for their eventual explosions to potentially affect our planet, there are at least 40 stars massive enough to become supernova or hypernovae. UY Scuti is just one of them. There's Eta Carinae, a luminous blue variable star that's already begun its death throes, experiencing massive eruptions that have made it one of the brightest stars in our galaxy. There's Betelgeuse, the red supergiant, in Orion that could explode at any time and would be bright enough to cast shadows at night. There's WR 104, a Wolf-Rayet star whose rotation axis might be pointed directly at Earth. potentially making it the most dangerous star in our galaxy. Dr. Phil Massey at Lowell Observatory has been cataloging these stellar threats for decades, and his research reveals a sobering truth. We live in what he calls a cosmic shooting gallery, surrounded by stellar explosions waiting to happen. The fact that Earth has survived for 4.5 billion years in this environment is either incredibly lucky or indicates that the threats are not quite as severe as the most pessimistic models suggest. But here's what's remarkable about our situation. These same dangerous stars are also what make complex life possible. The heavy elements in your body, the oxygen in our atmosphere, the iron in Earth's core that generates our protective magnetic field. All of it came from previous generations of massive stars that lived and died before our solar system even formed. We exist because of stellar violence, and we're threatened by that same stellar violence. It's the ultimate cosmic paradox. The universe's creative processes are also its most destructive forces. The stellar explosions that could wipe out humanity are the same types of explosions that made humanity possible in the first place. Paradox reveals something profound about the nature of existence itself. Life, consciousness, and intelligence emerge not in spite of cosmic violence, but because of it. The universe's tendency toward destruction is inextricably linked to its capacity for creation. You can't have one without the other. Professor Lisa Kaltenegger at Cornell University has studied how stellar explosions affect the development of life throughout the galaxy. Her research suggests that there's an optimal rate of stellar violence, too little, and there aren't enough heavy elements for complex chemistry. Too much in planetary atmospheres gets stripped away before life can evolve. Earth seems to exist in what she calls the Goldilocks zone of cosmic violence. Just enough stellar activity to create the conditions for life, but not so much that it prevents life from developing and persisting. We're living in the sweet spot between cosmic creation and destruction, but this sweet spot isn't permanent. As our galaxy evolves, the rate of star formation is decreasing. There are fewer massive stars being born now than there were billions of years ago, which means fewer supernova, fewer heavy elements being created, and potentially fewer opportunities for new forms of life to emerge. In a sense, we might be living during the universe's golden age of consciousness, the era when there's enough stellar activity to create complex chemistry and rocky planets, but not so much that planetary atmospheres are constantly being sterilized by gamma-ray bursts and supernova. Billions of years from now, when the last massive stars have exhausted their fuel and exploded, the universe will be a much quieter, safer place, but also a much less creative one. The stellar nurseries will shut down. No new heavy elements will be manufactured, and the cosmic conditions that made consciousness possible might never occur again. This means you're not just lucky to exist, you're lucky to exist now, during this brief cosmic moment when the universe is actively creating the building blocks of complexity and consciousness. You're living during the universe's most creative period, when stellar forges like Scuti are actively manufacturing the raw materials for future worlds and future minds. And this temporal perspective adds another layer of preciousness to your existence. You're not just a rare form of organized matter. You're a rare form of organized matter existing during the universe's most fertile epoch. What if I told you that your relationship with Scuti goes far deeper than just being made of stellar material? What if I told you that you and this massive star are connected by an invisible network of cause and effect that spans billions of years and touches every aspect of your daily life? Here's something that will make you see the mundane world around you in a completely different light. Every piece of technology you use, every bite of food you eat, every breath you take connects you directly to the nuclear processes happening in massive stars like Scuti. Let me show you how. The smartphone you might be using to watch this video contains dozens of elements that can only be created in stellar explosions. The rare earth elements in its screen, the gold in its circuits, the lithium in its battery, all of these were forged in the final moments of dying stars and scattered across space in supernova explosions. When you swipe across your phone's screen, you're literally touching atoms that were created in temperatures exceeding 1 billion degrees. But the connection goes even deeper. The silicon in your phone's processor was created when massive stars like UY Scuti fused oxygen atoms together in their cores. The process requires temperatures of about 2 billion degrees and pressures millions of times greater than Earth's atmosphere. Every calculation your phone makes, every photo it stores, every message it sends, depends on silicon atoms that survived violent death of ancient suns. Dr. Jennifer Johnson's research at Ohio State University revealed that the average smartphone contains measurable quantities of elements from at least 30 different stellar explosions. When you hold your phone, you're literally holding a condensed history of stellar death and cosmic violence, transformed through billions of years of evolution into a device that can connect you instantaneously to information from around this world. Think about that for a moment. The atoms in your phone have journeyed from the cores of dying stars, through the vacuum of space, into the primordial cloud that formed our solar system, through billions of years of planetary evolution, into the Earth's crust, through mining and refining processes, and finally into the device in your hands. Each atom carries with it the memory of stellar nucleosynthesis and cosmic violence, but the connections don't stop with technology. The food you eat for breakfast connects you to stellar processes in ways that would have seemed like magic to our ancestors. The calcium in your milk was created when a massive star burned silicon in its core. The iron in your cereal was forged during the collapse of a stellar core, in the few seconds when gravity temporarily overcame nuclear forces and created neutron matter. Even more remarkably, the photosynthesis that created your food depends on chlorophyll molecules containing magnesium atoms created in stellar cores. When plants convert sunlight into chemical energy, they're using the products of ancient stellar explosions to capture the energy of our current star. The entire food web of Earth is built on a foundation of stellar nucleosynthesi. Professor Tim Beers at the University of Notre Dame has traced the cosmic origins of elements in the human body, and his findings are mind-bending. The average person contains about 7 octillion atoms. That's 7 followed by 27 zeros. Of these, about 99% were created in stellar cores or stellar explosions. You are quite literally more star than Earth, more cosmic than terrestrial. But here's where the connection becomes truly profound. The nuclear reactions in your own body mirror. On a much smaller scale, the process is happening in stellar cores. When your cells break down glucose to release energy, they're performing a type of nuclear chemistry. The ATP molecules that power your muscles contain phosphorus atoms that were created in stellar explosions, arranged in molecular structures that capture and release energy in controlled bursts. Your heartbeat, powered by calcium ions that trigger muscle contractions, uses calcium atoms forged in stellar cores. Your thoughts, transmitted by electrical impulses that depend on sodium and potassium ions, rely on elements created by stellar nucleosynthesis. Even your emotions, the chemical cascades of neurotransmitters that create joy, fear, love, and wonder, depend on carbon, nitrogen, and oxygen atoms manufactured in dying stars. This means that when you feel awe looking up at you, why Scuddy, you're experiencing a sensation created by stellar matter contemplating its own origins. The very capacity for wonder, for curiosity, for the desire to understand the universe emerges from arrangements of atoms that were created in stellar cores. You are not separate from the cosmos. You are the cosmos, organized in a way that allows it to examine itself, question itself, and marvel at its own complexity and beauty. Here's what should fundamentally change: how you live your life, knowing that you are made of ancient starlight, that your consciousness represents billions of years of cosmic evolution, and that your existence is connected to the most powerful forces in the universe, should fill you with an unshakable sense of your own cosmic significance. But it should also fill you with responsibility. If you truly are the universe becoming aware of itself, and what you do with that awareness matters not just to you, but to the cosmos itself. Every choice you make, every moment of wonder you experience, every piece of knowledge you gain, becomes part of the universe's ongoing project of self-discovery. When you choose to learn about stars like U.Y. Scotty, you're helping the universe understand its own processes. When you share that knowledge with others, you're spreading cosmic awareness. When you feel amazed by the beauty and complexity of stellar evolution, you're giving the universe a way to appreciate its own creativity. Think of it like this. For nearly 14 billion years, the universe existed without consciousness. Stars formed and died, galaxies collided, supernova exploded, and none of it was observed, appreciated, or understood by any conscious being. The universe was like a magnificent symphony playing in an empty concert hall. Then, through a series of incredibly unlikely events, the formation of just the right kind of star, the creation of just the right kind of planet, the evolution of just the right kind of chemistry, the universe finally developed a way to listen to its own symphony. You are part of that listening apparatus. You are how the cosmos experiences wonder at its own beauty. This means your life has meaning on the deepest possible level. Not meaning assigned by human institutions or cultural traditions, but meaning embedded in the fundamental structure of reality itself. You are not an accidental byproduct of random processes. You are the universe's attempt to understand itself. And here's what makes this even more profound. Consciousness might be incredibly rare. Despite decades of searching, we haven't found any other conscious civilizations in our galaxy. It's possible that Earth represents the universe's only successful attempt at self-awareness within thousands of light years. If that's true, then your thoughts, your experiences, your capacity for wonder and understanding might be unique in this entire region of space. When you look up at U.Y. Scotty and feel amazed, you might be the only conscious being within 10,000 light years capable of that experience. This rarity makes consciousness infinitely precious. Professor Nick Bostrom at Oxford University has argued that if consciousness is as rare as it appears to be, then preserving and expanding it should be our highest priority as a species. Every human mind represents an irreplaceable piece of the universe's self-awareness, but consciousness isn't just rare, it's also fragile. The stellar explosions we've discussed could potentially end human consciousness entirely. A nearby gamma-ray burst, a supervolcanic eruption, a large asteroid impact, climate change, nuclear war, any number of threats could silence the universe's voice in this part of the galaxy. This fragility means that every moment of consciousness is precious. Every time you experience wonder, joy, love, or understanding, you're participating in something that might be unique in the cosmos. You're helping the universe experience emotions that might not exist anywhere else. And here's what should inspire you to live more fully. If consciousness is this rare and precious, then wasting it becomes a cosmic tragedy. Every moment you spend not engaged with the beauty and mystery of existence is a moment when the universe is not fully appreciating itself. This doesn't mean you need to spend every second contemplating stellar nucleosynthesis. But it does mean that developing your capacity for wonder, for learning, for appreciation of beauty and complexity is not just personally fulfilling, it's cosmically important. When you take time to really see a sunset, you're giving the universe a way to appreciate the beauty of electromagnetic radiation, scattered by atmospheric particles. When you feel love for another person, you're allowing the cosmos to experience the complex emotions that emerge from conscious beings caring for each other. When you create art, music, or literature, you're helping the universe explore its own creative potential. Your life matters on the scale of stars and galaxies. Your thoughts and experiences are part of the most important thing happening in the universe, the cosmos becoming aware of itself. This should fill you with both profound humility and unshakable confidence in your own significance. You are not just made of star stuff, you are star stuff that has learned to think, to wonder, and to love. You are the universe's way of experiencing beauty, meaning, and consciousness itself. And that brings us to the final, most mind-bending realization about your connection to UI, Scotty, and the cosmos. Here's the ultimate revelation that ties everything together. You are not just connected to UI Scotty and the cosmos. You are UI Scotty and the cosmos, experiencing itself subjectively from the inside. There is no meaningful separation between you and the stellar processes that created you. You are not observing the universe. You are the universe observing itself. This isn't mystical thinking. It's the logical conclusion of everything we've discovered about stellar nucleosynthesis, cosmic evolution, and the nature of consciousness. The atoms in your body were literally forged in stellar cores. The elements that make thought possible were created in stellar explosions. The energy powering your neurons came from fusion reactions in our sun, which burns with the same nuclear fire that burns in you. The study's core. Dr. Neil deGrasse Tyson captures this beautifully when he says that we are not in the universe. We are the universe, in the same way that a wave is not in the ocean, but is the ocean, temporarily organized into a particular pattern. You are a temporary pattern of stellar material that has organized itself into consciousness. But here's what makes this even more profound. If consciousness is the universe examining itself, then every human being represents a unique perspective on cosmic reality. When you look up at UI Scotty, you're seeing it from a viewpoint that has never existed before and will never exist again. Your particular combination of experiences, knowledge, and awareness creates a one-of-a-kind window through which the cosmos can observe itself. This means that your death won't just be the end of your individual consciousness. It will be closing of a unique cosmic perspective. The universe will lose a particular way of seeing, thinking, and experiencing itself. In a very real sense, when you die, the universe becomes slightly less aware of itself. But your life also means that the universe is currently more aware of itself because you exist. Every moment of your consciousness expands cosmic self-awareness. Every time you learn something new, understand a new concept, or appreciate a new form of beauty, you're literally expanding the universe's knowledge of itself. Professor Freeman Dyson once speculated about the ultimate fate of consciousness in the universe. He imagined a far future where conscious beings might find ways to survive the heat death of the cosmos, preserving awareness and information processing capabilities even as stars die and galaxies fade. If such a future is possible, then consciousness might be not just a temporary accident, but the universe's long-term strategy for understanding, and perhaps even controlling its own evolution. This possibility gives your existence cosmic purpose. You might be part of the universe's early experiments in self-awareness, a prototype for forms of consciousness that could eventually spread throughout space and time. The thoughts you're having right now, the wonder you feel when contemplating the cosmos, might be evolutionary stepping stones toward forms of consciousness we can't yet imagine. And here's the most beautiful part. None of this depends on you being special or unique as an individual. You don't need to be a genius, a saint, or a hero for your consciousness to be cosmically significant. The simple fact that you can think, feel, and experience wonder makes you a precious part of the universe's awakening to itself. When you look up at the night sky and feel small, remember that you're not small at all. You're made of the same materials as the largest stars, powered by the same nuclear processes, connected by gravity and electromagnetism to every other piece of matter. In the observable universe, your consciousness represents the culmination of nearly 14 billion years of cosmic evolution. The hydrogen atoms in your body are almost as old as the universe itself, forged in the first few minutes after the Big Bang. The heavier elements were created in stellar cores and scattered by stellar explosions across billions of years. The complexity that makes consciousness possible emerged through countless generations of cosmic evolution. You are not a separate thing observing the universe. You are the universe that has evolved the ability to observe itself. You are 13.8 billion years of cosmic history that has become self-aware. You are the cosmos experiencing itself subjectively. And that realization should change everything about how you see yourself, your life, and your place in the grand scheme of existence. You are not an accident or an afterthought. You are the universe's greatest achievement, its most complex creation, its pathway to self-understanding. Every moment of your life, you carry within you the nuclear fire of stars, the creative force of cosmic evolution, and the most precious thing in the known universe, the ability to be aware, to wonder, and to understand. Ui Scuddy, with all its massive power and stellar fury, exists in part so that beings like you can exist to contemplate it. The death of massive stars throughout cosmic history happened so that you could live to appreciate the beauty and terror of stellar death. The universe spent billions of years becoming complex enough to understand itself, and you are the result of that cosmic project. When you feel wonder looking up at the stars, that's the universe marveling at its own beauty. When you feel curious about how things work, that's cosmic matter investigating its own properties. When you feel connected to something larger than yourself, that's because you are something larger than yourself. You are the cosmos, experiencing itself from the inside. This is who you really are, a conscious, thinking, wondering piece of the universe that has awakened to contemplate its own majesty. And that makes you not smaller than the stars, but equal to them. A different, but equally magnificent expression of the creative power of the cosmos. The terrifying power of Ui Scuddy is also your power, because you and the star are made of the same stuff, governed by the same laws, part of the same magnificent, ever-evolving cosmic story. You are not separate from the universe's creative force. You are that force, manifesting as consciousness, wonder, and the capacity to understand. And that understanding should fill you with a sense of your own cosmic importance that nothing can diminish, because it's based on the deepest truths about the nature of reality itself. You are made of stars. You are the universe awakening. You are the cosmos experiencing itself. And that makes you absolutely magnificent. If you've made it this far in our cosmic journey together, you're clearly someone who appreciates the profound connections between human consciousness and stellar evolution. Consider subscribing to join a community of cosmic thinkers who share your sense of wonder about the universe. And remember, every time you share this knowledge with someone else, you're helping the universe expand its own self-awareness. But wait, there's something even more mind-bending we need to explore. Something that will make everything weave discussed seem like just the opening act of a far more incredible cosmic drama. What if I told you that Ui Scuddy, for all its terrifying power and massive size, is actually just a baby compared to the stellar monsters that dominated the early universe? What if I told you that the first stars to ever exist, the ones that made Ui Scuddy possible in the first place, were so massive, so incredibly powerful, that they make our current record holder look like a flickering candle next to a raging bonfire? Here's something that will completely rewrite your understanding of stellar evolution. the very first generation of stars in the universe, called population 3 stars, were absolute giants that could reach masses of 300 to 1,000 times that of our Sun. Scuti, at roughly 30 solar masses, would have been a lightweight compared to these primordial behemoths. Dr. Volker Braun at the University of Texas has spent decades modeling these first stars using supercomputers. And what he's discovered challenges everything we thought we knew about how large stars can grow. These population 3 stars formed from pure hydrogen and helium, the only elements that existed after the Big Bang, in an environment completely unlike anything in today's universe. Think of it like this. Imagine trying to build a house using only 2 types of materials, hydrogen bricks and helium mortar. That's essentially what the first stars had to work with. Without heavy elements to help cool the gas clouds during collapse, these primordial stellar nurseries operated under completely different physics than modern star-forming regions. The result was stellar monsters that defied every rule we see in today's universe. A typical population 3 star might have been 500 times more massive than our Sun, burned at surface temperatures exceeding 50,000 degrees Celsius, and shone with the brightness of entire galaxies. They were so luminous that a single star could illuminate an entire protogalaxy. But here's what's really going to blow your mind about these cosmic titans. They lived fast and died young in the most spectacular way possible. While Scuti might live for millions of years, these primordial giants exhausted their nuclear fuel in just 2 to 3 million years. And when they died, they didn't just explode. They became the universe's first black holes and scattered the first heavy elements across the cosmos. Professor John Wise at Georgia Institute of Technology discovered something remarkable in 2012 when he traced the chemical signatures of these first stellar explosions. Every heavy element in your body, the carbon, oxygen, nitrogen, and silicon that makes complex life possible, can ultimately be traced back to the death of these primordial giants. This means Scuti is actually a 3rd or 4th generation star built from the recycled remains of even more massive predecessors. The stellar nucleosynthesis happening in Scuti's core right now is only possible because previous generations of stellar giants created the heavy elements necessary for the complex nuclear burning processes we observe today. Here's where it gets truly mind-bending. We might actually be able to see these first stars. The James Webb Space Telescope, launched in 2021, is specifically designed to peer back to the era of first star formation, roughly 13.5 billion years ago. If the telescope's infrared sensors can detect the signature of population 3 stars, we'll literally be seeing the birth of stellar nucleosynthesis itself. Dr. Avi Loeb at Harvard University has calculated that if we can observe these first stars, we'll be witnessing the moment when the universe first began creating complexity. Before these stellar giants ignited, the cosmos contained only hydrogen, helium, and a trace amount of lithium. After they exploded, the universe suddenly had carbon, oxygen, silicon, iron, all the building blocks of rocky planets and organic chemistry.